jam-packed topic. Medyo marami tayong kailangan i-discuss dito. Okay? So, please bear with me and I will upload a copy of the video na lang for your reference. No? So again, medyo marami tayong discuss in 2 hours kaya kapit lang muna tayo. Okay? So our session for today, ayan. So our session for today is about chapter 6, which is on fundamentals of potentiometric titration, redox titration, and voltammetry. Okay, so this is the chapter outline that we will discuss. So itong second and third subtopic, may mga calculation dito, even until the fourth, no? But let's try to explain, no? This, no? This topic requires knowledge of titration and kailangan may alam ka na sa titration, may alam ka na rin dapat sa equilibrium. Okay? And a little bit of electrochem. So I think you have not started with electrochem pano with Sir Alex. No? But I will give you an idea. No? So discuss natin to briefly, but more details will be discussed in the lab. Okay. So, ayan. So let's talk about electrochemistry. Why is this important and why is this related to your field? No? So when you say electrochemistry, we are pertaining to a branch of chemistry that deals with the conversion of electrical energy and chemical energy. Okay? So one example would be our batteries, 'di ba? Kung yung battery natin, ano nandun sa loob nun? Chemicals lang yun eh. But it can produce electricity. Okay? So that means studying electrochemistry is important, no? Because our lives nowadays, no, primarily depend on them, no? Kasi yung cellphone natin, may battery yun, may mga chemicals yun that produces electricity. Our laptops, no? Our power grid, no? So basically, lahat ng mga bagay sa paligid natin na may battery, it is run by the concept of electrochemistry, no? Okay. So yun yung gagawin natin. And what is the possible application of this in your field, no? So remember that in your field, you are focused on quantifying matter, diba? So for example, if you want to quantify the glucose in your blood, no, you use glucometer. Okay. So in this glucometer, you have a strip, no, and this strip, dun mo ilalagay yung blood mo. Okay. So for example, you pinch this with a lancet, then yung dugo, syempre lalabas yung dugo. Yung blood na yon, ilagay mo siya dun sa container ng strip, no? And then what will happen there is that this system, no, or this device will actually pass through certain potential to your blood, no? Magpa-pass through siya ng kuryente doon. Okay. Kaya nga yung mga test strip ng glucose, may mga circuit doon, no? So, yun. Ganun gagawin na itong device na to. So, pag nilagay mo yung dugo dyan, magkakaroon ng circuit dito. Okay? So, yung kuryente dadaloy from the device to your blood, then back to your device, no? So, depending on the amount of the voltage or the amount of potential passed through the solution of blood, pwede nyo malaman yung concentration. Okay. Kunwari, mataas yung na-pass through na kuryente, ibig sabihin mataas yung glucose concentration. O kaya, kunwari, mababa yung na-pass through na kuryente, that means mababa glucose concentration. Okay? Ibig sabihin, related to, no? Okay. And another one is the pH meter. Okay, so we are familiar with this, no? I think familiar tayo nito during our high school days. What we do here sa pH meter is that we submerge the probe, no? Ito yung probe, yung dalawang nakatusok na yan. Ilulublob mo yan dito sa tubig mo. Then, lalabas yung pH meter. So, ano nangyari? Nung nilublob mo yung probe, lumabas yung concentration ng H or basically just the pH, no? Ibig sabihin na-measure mo yung dami ng ions mo sa solution. How was it done? Okay. So, paano ginawa yun? So, this device actually measures the voltage potential or the voltage difference of this solution and the reference. Mamaya may di-discuss tayo about this. So, nagko-compare lang siya ng voltages na kaya i-pass through ng solution. Okay? So, hindi mo ma-feel yung kuryente, but the ions can feel that, no? And yun, depende on how much voltage the solution can pass through, there is a corresponding concentration for that. Okay? So, ayun. So, yun yung uses ng electrochem, no, in the laboratory setup. You can either create devices that will measure the number of ions or pwede gumawa ka ng mga meters, no. Ayun. And of course, the other use of electrochem is the batteries, no. Ayan, sa batteries. Ito yung common. But again, hindi lang siya limited to batteries, ha. It can be applied to other metering devices. No? Okay. So, when we have an electrochemical cell, basically, ito yung battery. It is composed of electrodes that are deep in electrolyte solutions. No? So, kung nari, gagawa ka ng chemical cell, you should have liquids, no? Wherein merong mga metals submerged to them, no? And they were connected by a salt bridge. Okay? So, yan. So, ito yung setup no ko nung ginawa ko yung experiment na to sa students ko last 2019. Okay? Before the pandemic. So, before the pandemic, one of our experiment is to create an electrochemical cell. So, basically, in order to create a chemical cell, you should have two chemicals, no? You have two chemical solutions, then you have two metals, and then in between them, you connect them with the salt bridge, no? Okay? So, ito, in this particular case, this is magnesium, and this is copper. Okay, this is copper wire, copper solution, magnesium solution, and magnesium wire. And this salt bridge is just used to maintain the ion neutrality. No? Ilalagay mo lang talaga siya. Because without this, hindi gagana yung cell. Okay? So, nangyari sa amin, when we added the salt bridge in that maintains the neutrality of molecules here, yun, lumabas yung voltage reading. As you can see, hindi siya zero. It is 1 point something volts here. Ibig sabihin, may kuryente kang magagawa. But we are unable to power up we are unable to power up a LED light kasi kulang yung kuryente namin. Okay. So if we create series of this, then maybe we can power up an LED, no. Pero yun, kinulang kasi yung kuryente na napoproduce ng cell namin kaya hindi kami nakapagpailaw ng LED, just only the voltmeter. At least nakita namin that this setup really works, no? Hindi to gawa-gawa ng Illuminati, no? So ano 'yan, lumalabas talaga yung potential ng cell. Okay? So that is the electrochemical cell setup. Okay? And dalawa yung electrochemical cell natin. We have voltaic and electrolytic na. When you say voltaic, that is the electrochemical cell that is spontaneous, which produces energy. Okay? So again, pag sinabing voltaic, it produces energy or it generates electric current. Ibig sabihin yan, yung cell potential niya is positive. No? Positive yung voltage niya. Yan lang yung gusto ko sabihin dun. However, there is an opposite form of galvanic cell or voltaic cell. Ano yung opposite form niya? The electrolytic cell. So in electrolytic cell, in order for the reaction to happen, instead of it giving the electricity, ikaw yung magbibigay ng kuryente. Okay? Saan ginagamit yon? Yung electrolytic cell, ginagamit yan when we are coating the materials with metal. On this picture, we coated etong susi. I think susi ko ata to. Eto, susi ko 'to sa dorm dati. So, in order to coat this, no, with copper, so gano'n, we pass through kuryente. Kinuryente namin 'tong solution so that yung ions magiging, solid, made-deposit sila dito. Yun din yung ginagamit sa mga copper-coated materials 'no. For example, you have a copper-coated na lutuan, kinukuryente lang nila yun 'no. Lulublob nila dito, then kukuryentehin, then yun, copper-coated na siya. Okay, not spontaneous 'yun. Ibig sabihin 'pag nilubog mo yung metal sa solution na 'to, hindi 'yun agad mangyayari unless kuryentehin mo. Okay, so 'yun yung purpose ng electrolytic cell. Kinokuryente bago mangyari yung reaction. 'Pag galvanic or voltaic cell, hindi mo na kailangang kuryentehin kasi sila na yung magbibigay ng kuryente. One example of our galvanic cell is yung batteries natin. Ito naman ginawa namin dito yung hydrolysis setup. This is used by astronauts na sa spacecraft nila because you can see in the outer space ano wala lang in the outer space para magkaroon sila ng fuel, sometimes they use electrolysis no. Yung mga water systems nila, kinokuryente nila to produce fuel and oxygen that they can breathe no. Ayun. Yan lang. Okay, so more details of that will be discussed in your lab now. So I will not go in depth with this one. So sa lab nyo na yan. Okay, so remember that redox reaction, no? Ito madidiscuss to in depth sa lab, no? Sa redox reaction, there are two reactions happening. You have the reduction and the oxidation reaction. Okay? And when you say oxidation, it is losing electron. Ibig sabihin, maglalabas ng electron yung ions natin. And kapag sinabi natin reduction, yun yung magigain ng electron. Okay? So, yan. So, the reaction where the side of the system where oxidation happens is the anode. Okay? And the side of the reaction where the reduction happens is the cathode. Okay? So, ibig sabihin, sa anode, dun nangyayari yung oxidation. Yung cathode, dun yung reduction. Okay? So, my mnemonic for that is oxred. I mean, oxan, red cat. So, this is my mnemonic for this one. Meaning nun, ang oxidation nangyayari sa anode and the reduction happens at the cathode. Okay? So, oxan, red cat. No? So again, what is oxidation? Losing electron lang yan. And reduction is gaining electron. Okay? So if you haven't started yet with your lab, maybe blurry pa to. No? Pero once this will be discussed in your lab, then mas magiging clear to. Okay? So just wait for your discussion sa lab na lang. I think di pa kayo nag-start dun eh. Okay? Anyway, so yun. So a salt bridge, ito yung sinasabi ko kanina, in order to make uh, the voltaic cell work, you have to add a salt bridge. And what's the purpose of that? Just to maintain the neutrality of ions. Okay. So it maintains the neutrality of ions. Saan yan gawa? Sa gelatin na may asin. Ginawa ko dyan, the night before I did the experiment, nagluto ako ng gelatin, then nilagyan ko maraming asin. So yan, mamumuo yun. So solid to eh. Lalagay mo lang talaga siya doon. Okay. So that is the voltaic cell setup. Okay. So in theory, ito yung itsura niya. So you have a solution here, you have the solution there. Okay. So yan. This is the salt bridge, the one that connects this on this and that. Okay. So yung salt bridge yung nagko-connect ng dalawang ating containers, dalawang beakers, no. Then we have the electrode, the metal electrodes, and the solution. Okay. So typically, if we have this reaction, if we have this setup, the anode are written on the left side, and the cathode are written on the right side. No? So, ganun yung nangyayari. Yung anode usually nasa left, then yung cathode yung nasa right. Okay. And then what will happen, remember that yung anode, ito yung maglalabas ng electron kasi sabi nga natin, oxidation is losing electron. So, ibig sabihin, yung electron na malalabas nila, it will pass through from the left to the right, no? Where the reduction will accept the electron. Okay. So, dun niya, gagawin niya yung oxidation, ito yung maglalabas ng electron, then that electron will pass through from this to that, no, papunta sa kabilang side, where the reduction reaction will occur. And as the electron passes from here to there, may voltage tayo. Yun yung reason ba't gumagana yung batteries natin. So, in our cell phone devices, yung ating battery doon, may anode and cathode din, no? Usually, the anode is on the left side of the battery and the cathode is on the right side of the battery as well. So, ano mangyayari? If the anode of your battery loses electron, dadaan yun sa circuitry ng cellphone mo. Okay? So, dadaan yun sa processor, dadaan yun sa sa LED, no, sa OLED, sa retina display, no, sa mga iPhone, ganun. So, dadaan yung kuryente doon. Kaya gumagana yung ating cellphone. And then, yung electron na yun, babalik yun sa battery ulit. No? So, yan, tuloy-tuloy yun mangyayari until onti na lang yung ions mo dito. So, ano mangyayari? Lobat ka na. Okay? So, kung kunwari, gusto mo bumalik uli sa original power, you produce, di ba? You plug your device in power socket, no? So, big sabihin nun, pabaliktad na yung reaction. Bumabalik uli yung electrons kay anode. So, ibig sabihin, dumadami na yung charge ng battery mo. Okay? Tapos, kapag huhugutin mo siya uli sa saksakan, malulobat uli yan kasi yung electrons pupunta na naman sa kabila. Kung gusto mo i-charge, sasaksak mo yun sa battery, then baliktad yung mangyayari. Ito yung maglalabas ng electron pabalik dito. Okay? So, cycle lang yan, no? Yung mga nangyayari sa charging systems natin. Okay? So, ganun lang. If you want to determine the cell potential, when I say cell potential, basically voltage lang yun. Okay? So, voltage, if you want to determine the voltage of a cell, okay, so this is the equation to be used. E cell equals E cathode minus E anode. Okay, so this is the standard cell potential. Okay, so ito yung ginagamit natin to solve gano'ng karaming kuryente yung mapoproduce ng battery natin. Okay, kaya mapapansin nyo yung battery natin, minsan sabi 4 volts, minsan 1.5 volts, di ba? Paano nila nalaman yun? Itong equation yun. Okay? Kunwari, bibili ka ng AA battery. 1.5 volts na nakalagay doon. Ayun. Kaya bibili ka ng battery na D. 9 volts nakalagay doon. So, paano nila nalaman yun? Ito yun. Okay. So, this is the equation to be used. No? Okay. So, for example, we have this. So, for the cell potential of copper 2 plus, silver. Okay? So, how do we read this? Paano binabasa to? So, again, ito lang din yon. Ganito lang din yan. Okay? So, ganyan lang din yan. No? Yung nasa left side, yung oxidation, and yung nasa right side ay yung reduction. Okay? So, this is the anode. Dito yung oxidation. And dito yung cathode. This is the reduction. So basically, you are just looking for the cell potential of this one. Reduction to. So hahanapin mo lang kung ano yung value niyan. Okay? Okay. So hanapin mo yung value nito. Ano yung cell potential nito? Ano yung cell potential nito? Then saka mo siya i-plug in doon. Okay? So ang tanong, saan mo hahanapin yan? Dito sa table na nilagay ko. Okay? So hanapin natin yung ions na to. Copper 2 plus copper, silver plus silver. Okay. It doesn't matter if baliktad yung reaction dito sa table. Basta yung ions ay correct. Okay? So, hanap tayo ng species dyan. Ito, so, this is the equation for, oops, teka lang. Highlight ko na lang. Hindi pa nagpantay. Wait lang ha. Ayun. So, that is the cell potential for copper, no? Basically, hanapin mo lang to, yung Cu2+. It doesn't matter if baliktad or not dito sa table. Basta makita mo yung ions na yan. Okay? And then look for Ag+. Okay, so hanapin natin Ag+, Ag. Huwag nyo nga kabisaduhin yung table na to ha. Mamaya kabisaduhin eh. Hanapin natin yung Ag. I think wala dito sa table yung Ag, no? So, but let me look for the value. Okay? So, may iba pa naman tables tayo dito. Or hindi ko lang nakita na ayun, nakita ko na. Ang dami nakalagay eh. Nakaduling. Ayun. So, ayan. Okay? So, yun, nakita ko na. Paki-note na lang na. Okay? So, according to the table, yung copper, which is our anode, it has a potential of 0.34 volts. And yung silver plus 0.80 siya. Okay? So, yan. So, ano na lang gagawin mo? Since you know the cell potential of this side and that side, plug in mo na lang dito sa equation. Okay? So, just plug it na lang. So, you get E naught cell equals the cathode, which is 0.8 volts, minus the anode, which is 0.34 volts. Pag subtractin mo na lang sila, that will be 0.46 volts. Ganun lang. So, ayan, that's how you solve for the, that's how you solve for the cell potential. For standard solution. So, when you say standard solution, the concentration ay 1 molar. Okay? Okay. So, yun yung standard solution. We are assuming that the concentrations are 1 molar. Again, paano ito nakuha? Identify mo lang ano yung anode, ano yung cathode. If the system is written this way, ibig sabihin, if the system is written this way, ibig sabihin, yung nasa left side, ito yung anode, ito yung oxidation, and yung nasa right side, ito yung cathode, yun yung reduction. Pattern diyan sa setup kanina. 'Di ba kanina, nasa left yung anode, nasa right yung cathode. Ganun din pag ganyan yung itsura. Okay, ito yung left beaker, ito yung right beaker, and itong double line in between, that is the salt bridge, no? Okay, so it will be discussed, no? Ito madi-discuss sa lab, no? Don't worry. So, i-cover din to sa lab. Okay, so ganun lang. However, if we have a non-standard cell, okay, when we say non-standard cell, the concentration is not equal to 1 molar na. Okay, so if the concentration is not equal to 1 molar or the pressure is not equal to 1 atm, ayan, so non-standard na yan. Again, kapag standard, 1 molar concentration, 1 atm pressure. Pero kapag non-standard, that is not equal to 1. No? The concentration or the pressure is not equal to 1. So if that's the case, then we have to use a different equation, which is the Nernst equation. Okay, so we are going to use the Nernst equation. Okay, so the Nernst equation gives us the non-standard cell potential, no, equal to the standard cell potential minus 0.0592 over the moles of electron logarithm of Q. No, okay, so Q is the reaction quotient. Okay, so ano yung purpose uli ng ng Nernst equation? It allows us to solve for the non-standard cell potential. May kita mo naman kung non-standard yon. Kapag may bilog, standard yon. Pag walang bilog, non-standard yon. Okay? So, ganun lang. So, let's try that for this chemical system below. So, we have copper, copper 2 plus. Ang concentration nito ay 0.02 molar. Same as this one. So, you have silver plus 0.02 molar and silver. Okay? So, we know that this is our anode. Okay? And this is our cathode. Okay? So again, balikan natin yung table. Lista ko dito yung reactions and the cell potential. So according to the table on the right, no. So ito yung kay silver. Oops. Tumabingi uli yung aking line. Wait lang. Paki-zoom in na lang yung copy nyo ng lesson. Ayan. So kapag non-standard condition, kopyahin mo yung reaction, pati yung cell potential. Okay? So kopyahin natin. Okay, so let's copy that. So we have Ag plus electron producing Ag, and the cell potential is 0.8 volts. O yung sa copper naman, so you have Cu2 plus 2 electron producing Cu. Ang kuryente daw ay 0.34 volts. Okay? So, ganun, gagawin nyo. Kapag non-standard yung cell nyo, what you're going to do is to, di ba, hanapin mo anode, cathode dito. Ganun pa rin, katulad ng kanina. But this time, you have to copy the equation. You have to copy the equation because you will apply the Nernst equation dito. Okay? So, let me show you how. No? Pakita natin. Let me copy the Nernst equation. Okay. So, yan. Let's solve for the new E cell of Ag. Okay. So if it is standard solution, ang E neto ay 0.80 na. 0.8 na 'yon. Pero nakikita natin this is non-standard because the concentration is not 1 molar. Nakalagay dito 0.02 molar. Okay? So ibig sabihin I have to use the Nernst equation. Paano ko gagawin 'to? 'Di ba given na 'to? Okay? So this is given sa table. And yung standard potential daw ay 0.8. Okay? So pa-plug in ko yung dito. 0.8. Okay? So yan, 0.8 volts minus 0.0592 over ano yung mole ng electron. So yung Ne, that is the mole of electron. Just look at the equation. The mole of the electron is 1. So lalagay mo lang doon 1. Ln Q. Again, what is the reaction quotient? That is product over reactant, di ba? So, product over reactant. So, ang ilalagay mo lang ay yung reactant lang. Okay. Remember, yung solid, ito solid yan eh. Hindi ko kinopya yung state, pero solid yan. Yung solid, hindi yan sinusulat sa reaction quotient, no? Or even sa equilibrium constant. You don't write the solids, ang ilalagay mo lang ay yung ions. Yung electron, di mo rin isusulat, no? Kasi wala namang concentration yan eh. Okay. So basically, ang lalagay mo lang is tong ion, no? Which is the silver plus. So yung product, wala tayong isusulat doon. So we write 1. Yung reactant, we have the silver ion. So lagay mo Ag plus. Okay. So you construct the Q. You should be familiar with how to write the Q, ha? Kasi tagal na natin na-discuss yung reaction quotient. So sa product side or on the numerator, wala kang isusulat. No? 1 lang. Kasi this is solid. You don't write this. Sa reactant side, you have the ion, the aqueous, no? Ion. So ilalagay mo yun doon. Yung electron, di yan sinusulat din kasi wala yung concentration. Dumadaan lang yan. Okay? So hindi isusulat yan. So this is the equation. You plug in the concentration of silver according to the problem. That's 0.02. So we will get 0.8 minus 0.592 over 1. This is log pala, sorry. Logarithm 1 over the concentration of silver, which is 0.02. Pindutin na lang yan sa calcu. 0.8 minus 0.0592, sorry. Ayan. 0.592 divided by 1 log base 10 of 1 over 0.02. Okay. So the new cell potential decreased, no? So it is now 699 volts. Okay, so nag-decrease siya. So it is now 0.699, no? Okay. So as you can see, depending on the concentration, bababa talaga yung cell potential. Kaya nga yung battery natin nalolobat. Okay? Kasi nababawasan yung concentration ng ions doon. Okay? So, ano yung resulta? Nalolobat yun. Okay? So, to replenish that, kinukuryente natin yung cellphone natin. Okay? So, yan, nakikita nyo, the deviation from standard and the non-standard. No? So, pag standard, 0.8 yung volts niya, pero kapag non-standard ngayon, 0.699 volts na. Bumaba, no? Because bumaba yung concentration. Ito yung ginagamit sa pH meter. No? Pag bumaba yung voltage na nasa paligid niya, mababa yung pH or mababa yung concentration ng H. Okay, so they use the Nernst equation to measure the concentration of ions. Ayun. How about copper? Copper use the same equation lang. Okay, so let me erase this. So again, medyo mabilis ako ngayon ha. Pasensya na kasi ang dami pa nating i-cover eh. We are just slide 9 of 37 slides. But I will try to explain most of the items here. Okay? So for copper naman, for the copper electrode, so ang mole of electron doon ay 2 kasi nakalagay sa baba eh, 2. And the E-not cell, yung E na may bilog, E-not basa doon. E-not cell or the standard cell is 0.34. Log Q. Okay, so log Q, how to write Q uli? Product over reactant. Yung product, solid yan, so wala kang ilalagay, just the number 1. Yung reactant, copper 2+, no? So, ganun, concentration ng copper 2+. Okay? And then, plug in mo yung concentration ng copper 2+, minus 0.0592 over 2, log 1 over 0.02. So, same pa rin naman. Nagbago lang yung ibang given. Madidiscuss pa to sa lab, no? Don't worry. Dadaanan nyo rin to uli sa lab. Okay, so the new cell potential is 0.290 volts. As you can see, bumababa yung voltage kapag bumaba yung concentration. Okay, so ganun din sa cellphone natin, nalolobat yan kapag bumababa yung concentration ng ions. Okay? To replenish them, kinokuryente sila. Okay, so ganun. Ayan, so we use the Nernst equation. Nagamit na natin yung Nernst equation. Pero hindi pa natin nakuha yung cell potential, yung pinagsamang cathode pati anode na. Okay, so let me erase the Nernst equation here. So if you want to copy that, screenshot nyo na lang sa recording natin. So if you want to determine the cell potential, we still use the same equation kanina. E cell equals E anode minus E cathode. No? So the anode potential now is ito. Ito yung anode. Okay, so ito yung anode. So ito yung cathode. Ay, sorry, cathode minus anode pala, sorry. Nagtaka tuloy ako. So this is E cat minus E anode. I'm sorry. Ayan. So, yung pattern pa rin ito dito sa equation natin before. Okay? So, ganun. Once na makuha mo na yung mga E-cell, then i-pattern mo yung final answer mo dito. So, E-cell equals E cathode minus E anode. Okay? So, what's the cathode? The new cathode potential is 0.699 volts. And the new anode potential is 0.290 volts. Okay, so subtract mo lang 0.699, 0.29, 0.409 volts. So that's the new cell potential. Compare that with our answer kanina, 0.46. Ngayon, 0.4409. Okay? So bumaba yung cell potential. So yun yung ginagawa ng ating pH meter. By just determining the voltage of the solution, malalaman nyo yung concentration using the Nernst equation. Ang galing, di ba? So that means if kaya yan ng ating pH meter, that kaya din natin mag-solve. Okay. So ganito lang naman yung solving, no? Medyo nakaka-intimidate kasi ang daming equation, pero madali lang na. Basta gamitin mo muna to, then saka mo gamitin ito. Ganun lang, ulit-ulit lang to. Okay? So, etong problem na to, I will leave this to you as an activity na lang after the class. I-upload ko to sa worksheet. Okay? So, in this problem, we have the AgAgCl and the HClH2. Okay? So, ang gagamitin nating cell potential is for the AgAgCl and the HCl or the H plus to H2. Okay? So, ito yung mga cell potential natin dyan. 2H plus, 2 electron, H2, gas. This is a potential of 0 volts. Tapos yung AgAgCl, bibigay ko na sa inyo. AgCl plus L. Nasa table naman yun, don't worry. Ito ay may cell potential na 0.02. Yeah. 0.22. Ito yung standard potential. Itong sinulat ko dyan. Ang task nyo is to solve for the non-standard cell potential. So, ito yung mga standard cell potential. Ang gagawin nyo, solve for the non-standard cell potential. So, in solving for the non-standard cell potential, you use the Nernst equation. Okay? So, let me show you the Q. Kasi ang Q yung hinahanap nyo dito, di ba? Pag ipa-plug in nyo siya sa Nernst. The Q for this one will be chloride ion over nothing. Okay? Okay, so product over reactant. So, ang product Cl lang ilalagay mo kasi solid 'to. Ito lang, ang reactant ay wala kang ilalagay kasi yung solid di mo isusulat, yung electron hindi rin isusulat kasi walang concentration yung electron. Okay? So, yan. So, ito yung Q na ipa-plug in mo for this one to solve for the E of this. No? And then, for this one, sa baba, di ba naaalala nyo, magkaiba yung Kp pati Kc. No? Magkaiba yung pressure, magkaiba yung concentration. Di ba naalala nyo yung dati sa natin, sa equilibrium. Pinaghihiwalay natin yun eh. But this time, for equilibrium ng sa electrochemistry, pagsasamahin mo na yung pressure and the ions, okay? So hindi na siya separate equations. Wala na tayong Kc, Kp dito. Instead, you just combine the two, no? Whether that's pressure or ions, okay? So that means yung numerator natin naka-gas form yan. So ibig sabihin that's the pressure of hydrogen gas. And yung denominator, hydronium ion concentration yan. So H plus squared yan. Okay, so again, pag electrochem, pinagsasama na yung pressure and concentration. 'Di ba sa equilibrium hindi ganoon, 'di ba? Split 'yun eh, magkaiwalay 'yun. But this time sa electrochem pinagsasama na sila. So ito yung kanilang corresponding Q. So you just plug it here. You plug in the E0 cell and then yan, makukuha mo na yung E cell na ito, pati E cell na ito. Based on the equation, yung AgAgCl, ito yung anode. Kasi siya yung nasa left side and yung nasa right side, ito yung cathode. No? So, ganun. Always yung nasa left, yung anode, and yung nasa right, yung cathode. Pag nagbasa kayo ng textbook, ang makikita nyo is pag nagbasa kayo ng libro, no, instead of seeing this, ang nakalagay, E right minus E left. Ano ba yung nasa right? Cathode. Ano yung nasa left? Anode. So, yun. Cathode minus anode pa rin yun. Pero ang nilalagay nila sa libro, yung sa references natin, is E right minus E left. Okay? So, okay lang sana yun. Pero, again, it will be better if mas alam natin kung sino yung right, sino yung left, di ba? Yung right, yung cathode, yung left, yung anode. No? Okay. So, I will leave this to you to practice na lang. And I will upload the answer. Okay, so if we are going to determine the free energy change, no, so delta G is a form of energy, no. So if we want to determine the delta G, we just use the negative NF E cell. Okay? Eh, di ba na-solve na natin yung mga E cell kanina? Okay. So let's apply this equation. Okay, let's apply this, no, to this. Okay, so let's try to solve the delta G of this one. Okay. Delta G equals, okay, so let's assume this is at 25 degrees Celsius kasi the potentials we use are at 25 degrees Celsius. So the equation to be used at 25 degrees Celsius are the two. Okay, so kopyahin na lang natin. Ito na lang, negative 0.025. Hindi, ito pala, sorry. So we'll use this equation on the top. E-cell nga pala yung meron tayo, no? Okay. So E-cell yung meron tayo, so we will use this two equation. Okay. So plug in natin yon. Negative NF E-cell. Okay. So since standard to, so may bilog sila sa taas kasi standard sila. Okay. So what is N? N is the number of moles of electron. Okay. So ano ba yung moles of electrons na ginamit dito? Okay. So kapag nag-balance na kayo ng redox reaction sa lab, no? Sa lab to sa lab part talaga to. So sa lab part, malalaman nyo na 2 electrons to, yung electrons involved in the anode, and 1 electron dito. Okay? So just get their LCM, no? Yung common multiple nila, which is 2 times 1, which is 2. Okay? So kukunin mo yung LCM nila, 2 times 1 lang yan. So, 2 electrons. So, again, sa lab na lang yan, ha? What is F? F is Faraday's constant. Okay. So, what's the value of the Faraday's constant? That's, eto, bigay ko. Faraday's constant is 96485 coulombs. No? Okay. That's joule per volt. Yan yung unit na, joule per volt. Okay? So that's the Faraday's constant, letter F, 96485 joule per volt or coulombs, no? 96485 coulombs, letter C. Spelling ng coulombs is ganito. Yan. Yung letter C ay coulomb. So yan, plug in mo 96485 joule per volt. And the E naught cell is 0.46 volts. Okay? Plug in mo na lang negative 2 times 96485 times 0.46. Okay, so the answer is negative 88.77 kilojoules. No? Naka-kilojoules na sa akin. So, naka-divide na siya by 1,000. Okay. So, yan. So, or 88,700 something joules. Or, pag nilivide mo yun by 1,000, 88 kilojoules. Okay. So, if the value of delta G is negative, ibig sabihin nun, spontaneous yung reaction. Okay. So, if the value of delta G is negative, spontaneous yun. Ibig sabihin, the reaction will happen. Okay. But if the value of delta G is positive, non-spontaneous yun. Ibig sabihin, the reaction will not happen. Okay? So, hindi mangyayari yung reaction. Okay? So, take note of that. Let me write it here. If delta G is positive, this is non-spontaneous. Meaning ng non-spontaneous, hindi mangyayari. If delta G is negative naman, this is spontaneous. Ibig sabihin, mangyayari yung reaction. Again, don't forget, Faraday's constant, 96485 joule per volt or coulombs, no? 96485 coulombs. Same lang yan. Coulomb is spelled as this. Yan. Ayan. Paki-take note na lang. If you're going to use the other one, yung R, itong R, this is 8.314 joule per mole Kelvin. And the T is the temp. Okay. So this is the gas constant in energy form, which is 8.314. Okay. And the temperature should be in Kelvin. Ayun lang. So again, pag nagtataka kayo, no, bakit 2 electrons ginamit dito? Okay. Diba, N, pag sinabing N, mole ng electron yun. Okay. Pag nakita nyo yung N, bakit 2 ginamit dyan? Kinuha lang yung LCM, no? The least common multiple. So basically, malalaman mo that this reaction involves 2 electron, ito 1 electron. So kunin mo yung product nila, 2. Okay. So i-discuss din naman to sa lab, no? Kaya ma-recall to sa inyo. Okay. So pag nag-balance kayo ng redox reaction, dun lalabas yung 2 electrons. Okay. Okay, so with that, maybe I can proceed. By the way, may typo ako dito. So this should be 2 as well. Okay, so that's a typo. Instead of 1, dapat 2 yan. So kunwari, pinapahanap sa atin yung equilibrium constant for this reaction. For this reaction, solve for the equilibrium constant. Ito yung E-cell nila. So this is the Nernst equation for the copper and the silver. Okay, the reduction of copper and the silver. Pag pinapahanap yung equilibrium constant sa redox reaction, mas mahirap. Okay? Mas mahirap yung process. Okay? So let me show you how. Okay? So at equilibrium, we assume that the E cells are equal. Okay? So ibig sabihin, ito yung mga Nernst equation nila, 'di ba? Ito yung Nernst equation for the silver. This is for the copper. Saan nakuha yan? Ganito. So, saan nakuha yan? Dito lang. So, you write the reaction for this one. So, this will be 2 Ag plus 2 electrons. It will be reduced to 2 silver. The reduction for copper is ganito naman. Copper 2 plus 2 electrons producing copper. Okay. So, this is the reduction potentials, reduction reactions. Ipa-plug in mo to sa Nernst equation na ginawa natin. Okay. So, pinakita ko na yung Nernst equation kanina, how to use that. Ito, so that's E cell minus this, over N, mole ng electron, which is ito, 2, ito, 2. Okay. Log Q, so Q here is 1 over the reactant. No? Kasi solid tong silver. Ito, ion to. So, you're going to write this. 1 over Ag squared kasi may 2 na coefficient. And same thing as this one. Same process, pero this time copper 2 plus lang. Solid to, so walang nakalagay sa numerator. Copper sa baba na nakalagay. So, yan. So, anyway, so yan, yung Nernst equation nila. Doon yun nanggaling. And since we assume that the E cell are equal at equilibrium, we can combine these two, no? Pagsamahin natin yung dalawang equation. So, we get E naught cell for the silver minus 0.592 over 2 log 1 over Ag squared, no? Equal yan dun sa kabila. E cell ng copper minus 0.0592 over 2 log copper. Let us combine the equations. Pagsama-samahin natin yung E cell pati yung mga log. Okay? So, yung E cell lipat ko sa kabila. So, we will get E cell Ag minus E cell copper. Okay? So, lipat ko sa kabila to. So, you will get 0.0592 over 2 log 1 over Ag plus squared minus 0.0592 over 2 log 1 over copper. Okay? So, gagawin ko, so pinaglipat ko na yung E cell and this log. Okay? Iko-combine ko yung log. Okay? So, I will combine the logarithms. Okay? So, I will combine them. Paano? Paano ko i-combine yan? Kailangan same muna sila ng sign. So, ito positive. Ito magiging positive dapat. How? Paano ginagawa itong positive? If you take the reciprocal of this log, babaliktad yung sign nito. Property of logarithm yan. No? Remember the calculus. No? Sa Calc 1 to din i-discuss. No? Basic cal nung senior high school. If you inverse the log function, magiging baliktad din yung sign nito. Okay? So kung ni-reciprocate ko to, magiging positive to. Okay? So I will do that para mapag-combine ko sila. And so positive na siya. Then I can combine the terms. I can combine them. Okay. So I will factor out 0.0592 over 2. Okay. Then combine mo yung log. Nasa numerator yung copper 2 plus. Nasa baba yung Ag plus squared. Okay. So yan. Okay. So ginawa natin, binaliktad natin yung Q dito sa right side so that yung sign nila would be the same. Pag same na yung sign nila, then I can combine the log na. So, itong numerator na ito, lalagay ko lang dito. Pagsasamahin ko na sila. Okay. So, always take note that the sign should be the same when combining them. Okay. So, di pa tayo tapos. Medyo mahaba yung solving dito eh. Okay. So, medyo mahaba yung solving. What is this, no? What is this, no? Ano yan? Copper 2 plus over Ag plus. That is the equilibrium constant for this reaction. Yan yung K. Diba, if you write the K niyan, that's copper 2 plus product over reactant. Ag plus squared. So, ibig sabihin, this thing here, yung nakuha natin, is the K. No? That's the reaction. That's the equilibrium constant. So, okay. So, ibig sabihin, ito ay K lang na tong equation natin sa taas. Okay. So, that's the K. So, let me rewrite this. So, that E cell of Ag minus E cell of copper. 0.592 over 2 log K. Okay. So, this thing is just the equilibrium constant. And since K yung hinahanap natin, let's cross multiply this, no? We will get 2 E cell Ag minus E cell copper. Ito medyo mabilis na lang. Cross multiplication lang naman to. Okay. So, alam niyo na yung cross multiplication. Ayan. So, equal log K. And to cancel out the logarithm, you do the antilog. Okay. So, you just do the antilog. Or you can just plug in this thing sa calculator mo. Okay. So, this is the equation we need to use to solve for the K. Ang daming nangyari, no? Ganun talaga sa electrochem. Ang daming nangyayari. Okay. Puro equation. So, yan. Yan yung derivation natin to get the K. Okay, so ibig sabihin yan, if I ask you to solve for the K of something, you really have to derive it, no? Kailangan may Nernst equation ka. Then, from the Nernst equation, sabi natin at equilibrium constant, we assume that the E cells are equal, so you can combine them. Okay, so combining them, you will get this, no? And then, let's try to solve for the K. No? Kasi, try natin to solve for the K. Magbibigay pa ako nito sa worksheet, no? Para naman, may mapag-practicean kayo. With solution. Kasi, ito na naman yung last topic na mahirap. Ito na yun, no? Ito na yung last. Okay, so bakit may 10 dyan? Antilog, no? Remember the antilog that we use sa pH, no? Kapag gusto mo mawala yung log, edi mag-antilog ka. Okay? So, yan. So, that's 10 raised to whatever this thing is, you will get the K. Okay? So, plug in natin, that's 10 raised to 2 times, yung E cell Ag. Ano nga ba? Given to kanina, di ba? I think yung Ag ay... Ayan, so Ag is 0.80. Given na naman to, 0.8 minus yung kay copper, 0.34 divided by 0.0592. Okay, so let's solve for that. 10 raised to this. So the answer is 3 times 10 raised to 15. Okay, so 3 times 10 raised to 15. Okay, sa textbook, ang nakalagay ata sa textbook ay 1. Hindi. Ang nakalagay sa textbook ay 4.1 times 10 raised to 15. And okay, so 4.1 times 10 raised to 15 sa textbook. Kasi bakit? Yung e-cell kasi sa textbook ay 4 decimal places. Ako ginawa ko ganito lang eh. So this is actually 0.77 something. Ito ay 0.33 something. Okay. So, yan. Pero malapit naman na. Yun lang yung difference. Baka sabihin nyo, sir, iba naman sagot sa libro. Yes, iba yung sagot. Kasi yung e-cell nila ay mas maraming numbers. Okay. So, mas maraming numbers, ibig sabihin, mas magbabago to. But again, 10 raised to 15 naman siya. So, yeah. That's the yun yung idea. Nakuha pa rin naman natin yung times 10 raised to 15. So again, the answer in the textbook is 4.1. 4.1 times 10 raised to 15. Ang nakuha natin is 3 times 10 raised to 15. Because of the e-cell. Ang e-cell sa libro ay maraming numbers. Marami siyang decimal place eh. Nakaka-apekto yun dito. Okay? So hindi siya kasing easy ng equilibrium, no? Dami nangyayari, no? Pagko-combinein mo pa yung dalawang Nernst equation, dun mo makuha yung K, no? So I will give you a worksheet for this to practice, no? And I will pattern the exam. Ipa-pattern ko yung exam dito sa ganap natin dito. Okay? So pero while waiting for the worksheet, weekend ako nag-upload ng worksheet, diba? Okay, so while waiting for the worksheet, you can try this. Yung e-cell nito ay nasa table kanina. Binigay kong table. Okay. So you write the Nernst, no? Let me show you the pattern. Gawa ka ng Nernst, combine e-cell, pagsamahin mo sila, then solve for K. Okay. Solve for the equilibrium constant. Let me write the equilibrium constant for this one. That is Fe2 plus squared I3 minus over Fe3 plus squared I minus 3. Okay. So, ayan. Ito yung mga ito yung mga cell potential natin. So, ito yung reduction potentials. Wala kasi dun sa table kanina. Kaya bibigay ko na. So, sinave ko siya dito sa aking PowerPoint. So, wala to sa table dun sa binigay ko sa previous slide. Kaya, ayan na yung reduction potential nila. Okay. So, use this E-NOT cell. So, ito yung mga E-NOT cell nila. Yan yung gagamitin mo sa Nernst equation. Okay. And you need to use this when writing Q, no? Okay. So, yan. Aqueous, aqueous. This is charge. And aqueous and aqueous. Okay, so I will leave this to you to practice, no? So please take note na lang, and I will upload the answer by weekends. Now let's proceed. Redox titration. So remember, kapag acid-base titration, ano nangyayari? You have acid and you have a base, no? And one way to monitor the progress of the titration is to determine the pH, di ba? So, di ba, pag acid-base titration, ganon-ganon. pH, then you have the volume, no? Pwedeng ganyan, pwedeng ganito, no? Pag diprotic, 2 beses, no? Okay. Pag triprotic, 3 times, no? So, ganun sa acid-base titration. But for redox titration, ano napapansin nyo yung sinosolve natin? Cell potential, E-cell, yung kuryente na mapoproduce nila. Okay. So, since we are solving for the cell potential, then the graph should be in terms of E-cell and the volume of titrant. No? Same pa rin naman ang itsura yung curve, no? Nagbago nga lang yung vertical axis, no? So, pwedeng ganyan, pwedeng ganon, okay? So, ganon. And typically, isa lang yung inflection point natin. Okay, so isa lang yung inflection point compared to acid-base na ang daming nangyayari. For titration, redox titration, isa lang. Okay, so again, take note that the E cell is the y-axis, hindi na pH. Ang pH pang acid-base lang, pero kapag redox E cell, okay? Kasi yun yung sinasolve natin using the Nernst equation. Okay? These are the equations necessary to carry out the calculation for the the calculation for the E cell. Okay? So, ang initial, ito compared to acid base, no? 'Di ba may equation tayo for initial? But for redox, we cannot solve for the initial. Hindi ka talaga makakuha ng initial answer. Okay. Bakit? Ano yung possible reason dito? Yung equilibrium constant. Okay. So possible na ang problema dito is the equilibrium constant, no. Hindi kumpleto yung info mo about the concentration of the products over reactants. O, wala kang complete info about them kasi hindi mo alam yung ions nila initially. So walang equation na ginagamit doon. Okay. So typically kapag redox titration, always pre-equivalence, equivalence, and post-equivalence lang meron tayo. For initial, wala tayong equation for that. Okay? So wala talaga. Ayan, no talaga yan. For pre-equivalence, equivalence, and post-equivalence, so let's briefly discuss this, no? Pag pre-equivalence, remember, mas maraming analyte kaysa titrant, no? So in redox titration, that means that the equation to be used is this one, the Nernst equation for the analyte, no? So you should be familiar with this Nernst equation for the analyte. Okay? Kasi ang ating species ay mostly analyte, no? Now, how will you solve for the Q? To solve for the Q, just use this equation, MAVA minus MTBT over MTBT. Okay? We just follow this equation. At post-equivalence, mostly titrant tayo. So that means the Nernst equation to be followed ay yung sa Nernst ng titrant. So that's ET equals E naught T minus 0.0592 over mole electron log Q. And to solve for the Q, ito yung gagamiting equation. Molarity titrant, volume titrant over MTBT minus MAVA. So, medyo similar siya with acid-base titration. Oh, yes, medyo similar siya with acid-base titration. So, ipa-plug in mo lang yung mga yan. For equivalence point, iba yung itsura ng equation. All are equivalent. Okay? So, ang solving for E cell dyan is ganito. 2E system equals A, E analyte plus B, E titrant. Where A and B are the moles of the analyte and titrant. Okay, so let me show you briefly bakit naging ganito yung equation natin. Bakit naging ganyan yung equation natin. So let's have this example. So we have iron 2 plus to iron 3 plus, cerium 4 plus to cerium 3 plus. So this is a redox process. Okay, so at equivalence point, no, we always assume that the E cell is equal to the E of the system. Okay. So, ganun ginagawa natin. At equivalence point for redox titration, E cell is equal to the E of the system. Okay? So, di ba dapat ano to? E cell. Ito, dapat E cell yan, di ba? So, ngayon, sabi nga natin, pag redox titration at equivalence point, the E cell are the E system. Yun na yung pinagsama na. No? Okay, so kaya ganyan yung nilagay ko. E system. So this is the Nernst equation for the reduction of copper. Ito, for the reduction of this one. So let me write the equation for the reduction. So this will be cerium 4 plus. Etong mga reduction nakikita to sa table, no? Yung sa table na binigay ko. Kaya hindi mo kabisaduhin yan. Kasi given yan. Okay? So, don't worry. Di-discuss pa ulit to sa lab naman. Ayan. So, ito yung reduction reaction. Again, always, kapag nagre-write ka ng Nernst equation, doon ka sa reduction reaction kukuha ng equation. And this is given na sa table to. Yung table na pinakita ko kanina. Ito. Ayan, nandito sila. Ayan. Kulang pa yan actually. Magpo-provide ako ng mas kompletong table. Okay, so this is the reduction reactions. You write the Nernst equation following this one. Okay, so yan. 3 plus lang pala yun, sorry. So this should be 3 plus. Kamali ako ng tingin. So 1 electron lang. Okay, so yun. So 1 electron, cerium 3 plus, cerium 4, iron 2 plus, iron 3. Okay, product over reactant, 1 electron. Okay, so doon ang galing to lahat. Lahat ng Nernst galing sa reduction reactions. So if you add the two equations, you will get 2E system equals this plus this, ito plus ito, minus, pinagsama na to, log of this. Okay? So let me bring that to the next slide. Okay? So ito. So this is now the Nernst equation at equivalence point. Using stoichiometry at equivalence point, we know that this is equal to this, that is equal to this. No? Meaning lang nun, kung ano concentration nito, yun din concentration nun. Kung ano concentration nito, yun din concentration nun. Okay? So, yan. So, whatever the concentration of this one is, yun din yan. And same as this one. Di ba yun din naman sinabi ko sa acid-base titration. Kung ano yung amounts nila, they are equal. Okay? So, in-apply din natin yung dito. So, kapag equal to lahat, so, kapag ito ay equal dito, ito ay equal dito, then that means we can cancel out the entire equation. We can cancel out everything. Log 1 is 0, so mawawala to. Then we have this equation. Okay? So solving for E system, you just divide it by 2. Okay? So the general formula actually is this one. For redox reaction, whose coefficients are equal to 1, the equivalence point equation is this. E system equals E cat minus E anode over 2. Okay? So ganun lang. But this is again, ang coefficient dapat dito ay equal to 1. Kasi kapag equal to 2 or others, magbabago to. Magbabago yung sagot natin dito. Okay? So, I will not give any of those, but in the worksheet, I will add one of them. No? Maglalagay ako ng isang ganong example sa worksheet. Pero sa ating quiz, hindi na ako magbibigay ng ganon. Para masundan nyo tong equation na to. Okay? Para masundan nyo tong equation na to. Okay? So, ang solving na to, maybe sa worksheet ko na lang gagawin lang din. Okay? Kasi again, apologies no, parang nagmamadali talaga tayo. Yes, medyo nagmamadali tayo because we have a very limited time. Okay? So, yung solving na to, yung solving for the E-cell, no, I will upload the answer in the worksheet. But let me give you an idea how to start with this one. Okay? So, di ba, this is titration. Ibig sabihin nun, first step parate is to solve for the VTEP, no? Hanapin mo yung equivalence point always. The volume of titrant at equivalence point. Okay? So, let us do that. Okay? So, ito yung analyte kasi siya yung unang sinabi. Di ba, ganun yung ginagawa natin sa acid base, di ba? Ganun din dito. Kung sino yung unang sinabi, yun yung analyte. Then, ito yung titrant. Okay? So, at equivalence point, we show that the mole of analyte is equal to the mole of titrant. Okay? So, we use MAVA, MT, VT. So, since hinahanap natin si VTEP, volume of titrant at equivalence point, so this can be written as MAVA over MT. You just plug in the given equations. So MAVA 50 times 0.1 divided by the molarity of titrant 0.1. So the VTEP is 50 ml. Ito yung equivalence point. So ibig sabihin, ito lahat ay pre, ito ay post. Okay? And you know the equation to be used kapag pre-equivalence point ay yun sa analyte. So that's EA, E naught A, minus, I'm sorry for that. It should be minus 0.0592 over N log Q. And for the post-equivalence, that's the titrant equation, ET naught minus 0.0592 over N log Q. Then, you know how to solve for Q. Binigay ko na sa table. Plug in na lang yung MAVA, MTBT. No? So, yun. I will upload the answers na lang. Okay? So, pasensya na. I'm quite in a hurry because we have a very limited time for a very long topic. Kaya yun. So, sa worksheet ko na lang upload yung answer. But this is the answer. Ayan. So, this is the answer. Okay? So, take note of the equations na gagamitan per step na. So, binigay ko na sa table yon and this is how it looks like. Ito yung itsura ng redox titration curve. Similar siya with the acid base. The difference is that we cannot solve for the E naught. Na, we cannot solve for the V equals 0. Na, yung initial, wala ka talaga masasolve for that. You can only solve for anything in the pre at equivalence and the post-equivalence. Pero yung initial, hindi mo talaga siya masosolve. Okay? Kahit anong libro halugugin nyo, wala kayong makikita doon. Walang equation. Because again, the information is incomplete. No? Yun yung assumption. Kaya wala tayo doon. So, ganun lang. So, we just have 3 stages. And same thing for this one. So, this is, ang coefficients naman niya ay 1. I gave the standard potential. Okay. So you can apply the equation before. Again, this is the analyte. And this is the titrant. You solve for the VTEP. The VTEP for this one is 25 ml. Okay. So this all are pre and this all are post. Okay. So ganun. And you apply the necessary equation. Okay. Yung pag nagsosolve kayo ng Q, yung solving for Q ay nasa table na rin na binigay ko earlier. Okay. So, I will upload the solution sa worksheet. So, pasensya na guys, na medyo naghahabol talaga tayo. Lapit na matapos yung semester. Okay. So, yan. I will upload the solution indicating the individual calculation para masundan nyo. Okay. Parang acid-base titration lang din naman to. Don't worry. Next one. Ito, puro concept na lang tayo. Wala na tayong solving. I thank you, Lord. Yan. Kapag unat na din. Okay. Wala na tayong solving. Thank you, Lord. Okay. So, let's talk about redox titration indicator. Likewise, with acid-base titration, we also use indicators for redox systems. No? Okay. So, these are some of the common redox processes. So, we have the iodimetry, iodometry, permanganate, and dichromate method. Okay. So, maybe nagtataka kayo, anong pinagkaiba nitong dalawa, iodimetry and iodometry? Bukod sa letter I at O na difference, ganito ang difference niyan. Okay? So, pag sinabi nating iodimetry, this is used to quantify reducing agents. Ito ay para sa mga reducing agents. No? And for iodometry, this is used to quantify oxidizing agents. What are reducing and oxidizing agents? I-discuss sa lab yun. Don't worry. So, i-discuss siya sa lab. Na? So, I will skip on that. Na? So, yan. So, magkabaliktad sila ng purpose. So, iodi, this is used to quantify reducing agents. Iodo, this is used to quantify oxidizing agents. So, ito yung mga titrant that are used and these are the indicators. No? Commonly, for iodimetry, we use starch. Kasi in biochemistry, you will learn that yung starch, it reacts with iodine, no? And the solution will be color blue. Okay, so may ganyan yung kulay ng solution, kulay blue at the end point. Pag naging kulay blue na yan, stop ka na. Okay. So yan. What else? Sa permanganate naman, this is, we don't use any indicator. This is self-indicating because yung titrant ay colored. May kulay na to eh. So, ibig sabihin, pag lumabas na yung kulay ng titrant, tapos na yung titration. Okay? So, for example, in this picture, you have a clear one, then pag endpoint ka na, yun, lumalabas na yung kulay ng titrant. Okay? So, ganun. So, that's from colorless to purple. It's self-indicating kasi may kulay na yung titrant mismo. Okay? This is sensitive to light, kaya ginagawa namin to in darkness. Okay? Pag nagta-titration kami, madilim yung room. Okay? So, we shut all the lights. We only use dim lights, no? When titrating with permanganates. Kasi ang permanganate nasisira to in the presence of light. No? And we have dichromate na indicators diphenylamine. I can find the picture of the color transition, but from colorless to purple lang din siya. So same, medyo same dito. Okay. And those are the titration indicators for different methods in redox titration. And also, before you start titrating, you have to use auxiliary oxidizing and reducing agents. No? So what are these auxiliary? So these are used to convert the analytes into the desired form. The problem with redox titration kasi is that in the presence of air, our substances may react with it. No? Okay. For example, yung ating bakal, kinakalawang yon in the presence of water and the air because the air oxidizes the metal. Kaya yun, kinakalawang siya. Okay? So, ganun din sa titration, sa redox titration. They are sensitive to the air. That's why you have to you have to pre-reduce them. You have to add these auxiliary substances, no? Para ma-convert sila into the desired form so that they will not react with the air. So, hinahalo lang yan sa kanila. For example, pag reducing agent, ito yung mga chemicals, no? The Jones reductor, the Walden reductor. So, this is used when reducing the analyte. If your if your analyte is an oxidant naman, you use any of this. Sodium bismuthate, ammonium peroxydisulfate, and hydrogen peroxide. So hinahalo lang sila sa sa analyte. That is not the same with acid base, no? Kasi sa acid base wala tayong dinadagdag sa analyte other than the indicator. Dito, bukod sa indicator, maglalagay ka pa ng mga chemicals na to so that our analytes will be on the desired ionic form. They will not react with the air, no? Ayan. Let's talk about standards, no? So, ang standard kapag acid base, either HCl or NaO, no? Or potassium hydroxide. For titration naman, the standards are this one. So, if you want a reducing titrant, you need iron 2 or sodium thiosulfate. So, yun yung ginagamit natin as reducing titrants. If you want oxidizing titrants, you use potassium permanganate or cerium 4. Okay? So, yun. Ayun, nothing more. Yun lang talaga yung info niya. Yan. So, ganun lang. Okay, so we're done with the redox titration. Now, let's proceed with the other concepts. No? Potentiometry. Okay, so potentiometry, this is similar with the redox titration that we discussed. No? So basically, you are comparing the potential difference of the two systems, the anode and the cathode. No? But in potentiometry, instead of referring them as anode and cathode, we refer them as the reference and the indicating electrode. Okay? So compare yan sa kanina, compared sa kanina, 'di ba kanina anode cathode, ngayon reference indicating. Okay? So reference electrode, indicating electrode. Yun na yung tawag natin kapag potentiometry. But still, the same concept pa rin. It follows the Nernst equation. So one example of the potentiometry application is the pH meter. Okay, so let me skip that. So the use of electrodes. Ito yung mga nasa pH meter na yung diniscuss ko sa earlier slides. No? So ang potentiometry ginagamit to sa mga electrodes, no? Such as the pH meter. And what are electrodes? These are used to measure voltages. No? And dalawang uri ng electrode will have the reference and the indicator as said kanina. Okay. If we have reference electrodes, dalawang uri yan. You have the primary or the secondary standard. Kapag primary standard, we use the SHE or the SHE. SHE tawag namin dyan eh. The standard hydrogen electrode. So that means the chemicals inside is the hydrogen gas. Okay, for the primary. For secondary, we use the calomel, okay, or the silver chloride or the saturated calomel electrode. Okay? So yun yung difference nila, no. Kapag primary reference, ang gamit ay She, ano, hydrogen electrode, standard hydrogen electrode. Kapag secondary primary reference standard naman or electrode, gamit ay silver. Okay? So, papansin nyo, ba't gamit na gamit yung silver dito? Kasi nga, this redox titration dates back in 18th century, no, wherein silver yung abundant na element na alam dati. So, dati pa to. No? Kaya until now, ganun pa rin ginagamit. No? Nakasanayan na. Okay? Kaya puro silver ang ginagamit. So, ito yung reference. No? So, yan. So, the reference is the standard hydrogen electrode and the silver chloride or the calomel. The potential of the She is 0 volts according to the table we just used last time. So 0 volts yung standard potential nito. Okay? So kung titignan yung table, 0 volts yan. Itong silver chloride, I'm not really familiar pero nasa table yan. Okay? So yan. Kunwari, tinanong kayo sa final exam, what is the potential of the SHE? Ang sagot doon, 0 volts. No? Kasi yun yung nakalagay sa table. Again, anong table yung pinapatukuyan ko? Ito. Ayan. Magbibigay pa ako ng maraming ganito. No? So wait nyo na lang yan. Okay? So ito puro concept na lang. So chill na tayo. So for indicators naman, again, kapag potentiometry, you have the reference and then you have the indicator electrodes. So the reference, dalawa lang yun, primary or She, o kaya secondary, yun yung silver chloride or standard calomel. Okay? So kapag indicator naman, we have 3 types of indicators. Okay? We have the metal indicators, the membrane indicators, and the ion selective electrodes. Electrodes pala. Okay. So let's differentiate them. Kapag metal indicator electrodes, sa tingin nyo, ano yung ini-indicate nila? Di metals. Okay. So metals yung mini-measure nila. Okay. So metal sila, metallic form sila. Okay? So mga metals ito. Ito yung mga nilulublob nating bakal. Okay? So ano yung mga uri ng metal indicator natin? We have the first kind, second kind, and the third kind. No? Kapag first kind, metal rod. No? Ibig sabihin, bakal talaga mismo ilalagay mo. Lulublob mo yung bakal na yun. Kunwari, copper wire, magnesium wire. Doon 'di ba sa pinakita kong picture, magnesium and copper wire nilagay ko. Ayun, first kind 'yan. Okay? Pag second kind naman, these are metals coated with precipitate, no? Such as the calomels, no? Okay? So hindi to common masyado. Okay? And the third kind is we use inert electrode. One example of the inert metals ay platinum or nickel. Pero commonly platinum. Okay? So let me erase the nickel. So instead na metal na copper ilagay mo, platinum ilalagay mo. Kasi yung platinum, hindi siya matutunaw. Okay? Kaya yun yung nilalagay namin. Okay? So yun na yung difference. Kapag metal indicator, it is three types. First kind, metal rod, bakal mismo. Second kind, yung bakal. Then on the surface of it, you have the precipitates. No? Okay? So bakal with with precipitates on the surface. Pag third kind, you use inert electrodes, the electrodes that doesn't react with your solution. Basically, that's platinum. Okay, platinum ang ginagamit. Medyo hindi common to kasi mahal ang platinum. Okay, kaya hindi ginagamit to sa lab masyado. Mostly itong dalawa lang. Membrane electrodes, these electrodes are used to determine the p-values. So ito yung ginagamit sa pH meter. If you want to determine the P of the calcium, you can also use a membrane electrode and for nitrate. So saan ginagamit yun sa P-calcium meter? May ganong meter na P-calcium meter. Ginagamit yan kapag sa tubig, no? Kunwari, you work at Maynilad, no? Or MWSS, no? Okay. Pag nag-work ka sa mga ganon, Manila Water o kaya Maynilad, ginagamitan nila yon maka namin, kala mo nagtrabaho doon. Okay. So ginagamitan nila yon ng PCA meter, no. So it measures the calcium of the water. Okay. Ginagamit yon to determine if hard yung water or soft, no. Kapag hard water, ibig sabihin nun maraming minerals, no. Medyo pangit yon kasi kapag maraming minerals yung tubig natin, yung gripo natin, may buo-buo na lalabas doon. Okay. Tsaka kapag nagpakulo ka ng tubig na may minerals, no, for example, calcium, yung takure mo, yung kettle mo, magkakaroon yun ng kulay puti sa gilid. Calcium yun. Medyo familiar ba kayo sa ganong phenomena? Okay. So, sa probinsya, typical yon kasi yung tubig na ginagamit nila is yung nasa ilalim ng tubig, nasa ilalim ng lupa, yung balon. Okay. So, yung balon, maraming calcium doon. No? So, kapag pinakuluan mo yung tubig galing sa balon, may mamumuong kulay puti sa takore, no? Ang kulay puti na yon, that is the calcium. Okay. So, yan. So, share ko lang. So, yan. Baka kasi nakikita nyo sa bahay, no? Baka uy, ba't ang puti ng takore na to? Ibig sabihin nun, hard water yon, maraming calcium. Okay. So, ginagawa ng Maynila, they minimize that, no? So, they determine, kapag sobrang daming calcium, iti-treat na nila yung water para umonte yon. Kasi yun nga, yun yung problem with calcium, namumuo sila. Okay. So, pwedeng masira yung pipes. Ang mahal-mahal pa naman ng pipes. Kaya, itong nitrate, this is used naman sa mga nasa fertilizer industry, no? Mga agricultural chem, mga agriculturist, no? Mga magsasaka. So, they want to determine the nitrate content of the soil. So, itutusok nila tong indicator electrode sa lupa mismo or sa solution ng lupa. Okay. So the purpose is to determine if maraming nitrates, no? Because again, nitrates are necessary for the plants to carry out nitrogen fixation process. Bigla tayo napunta sa biology, no? Ganun yung chemistry, no? So it is really a central science, no? Ion selective electrodes, ito naman yung ginagamit for specific ions, no? These are very expensive, no? For example, gusto mo ma-measure is lead, no? Lead ions gusto mo ma-measure, do you use ion selective electrodes? But these are very expensive. No? Naging familiar lang ako with this one because the director of the Philippine Nuclear Research Institute, which is Dr. Adoracion, basta si Dr. Resurrection. Isa siya sa mga board examiners sa chemistry. So nakita ko siya before ako mag-board exam, na parang sabi ko, ma'am, pa-bless po kami. Alam ko nagpaganon kami sa kanya. Kasi sa PNRA ako nag-OJT, tas doon siya nag-work. Bale, during our interview, sabi namin, ma'am, pa-bless po kami kasi magbo-boards na kami next year. So sa kwento niya sa amin, yung thesis niya is about ion selective electrodes in the air, no? So bale, ang sabi niya doon, yung electrode daw na yun, expose mo lang sa hangin, it can detect the ions present in the air. Galing, no? Pero ang sakit niyan sa ulo, grabe. Okay. So, ayan, last part, voltammetry. So, in voltammetry, this is another electroanalytical technique that uses voltage. I mean, the current, no? Okay. So it measures the current by varying the voltage. Are they related? Yes. If you could remember the VIR law in physics, if you vary the voltage, the current or the ampere, no, changes, no. Assuming that the resistance is constant, no. Bigla tayo naging P6. Ganun talaga. Okay. So in voltammetry, that's the changing of voltage and current na. Yun yung binabago mong parameters here. Iba yung itsura ng graph nito. 'Di ba sa potentiometry and sa redox puro ganito lang. Okay, puro ganyan. For voltammetry, iba itsura niyan. Pa-circle. Pa-circle 'yan. So super weird tong topic na 'to. Pa-circle 'yan eh. Ang cute nga nun eh. Pero hindi ko na i-discuss masyado kasi hindi naman kayo BS Chem. Okay. Pero pa-circle yung itsura ng dito. Ng titration curve. Okay. So, ayan. So, by changing the current and the voltage, it will give you the voltammogram. Okay? And the voltammogram is a very unique graph, no? So, ito yung itsura ng voltammogram. Let me show you. Ito. And so, pa-circle siya. Circular siya. Hindi siya technically circle, no? Pero ayan, parang duck. Pero ganyan yung itsura ng voltammogram. And by changing the potential and by changing the voltage, pwede mo measure yung potential. Okay? So, yan. So, ganyan yung itsura niya, pa-loop, na naka-loop siya. Okay? So, that is a very weird graph, no? Okay? So, in voltammetry, there are it is a three-system process. So, you have the working electrode, the reference electrode, and the auxiliary electrode, and they are connected in this diagram. We will not focus on that too much. Okay? So, kapag working electrode, usually, ito ay mga mercury dropping electrodes. Literal, may pumapatak na mercury doon. Okay? So, in this electrode, may papatak dyan na mercury. Ayan. From small mercury drop to flat platinum disc. No? So, other than mercury drop, pwede rin daw pala yung platinum disc. No? So, pwede ito circle to na platinum na sinilulublob mo yun talaga. So, mapansin mo, mercury to, so medyo delikado to. So, this is quite used in a rare, ito ginagamit to in rare experiments, no? Pang master's degree na to eh. Okay. So, yun lang. For reference electrodes, the reference electrodes usually are the calomel and the silver chloride. Same with the potentiometry, no? Yung reference electrode doon. So, this is the secondary electrode doon, di ba? Remember. The auxiliary electrode usually are platinum wire. So the platinum wire or the auxiliary electrode, it helps lang to facilitate the changing of potential. Okay. Ayan. So siya yung nagme-measure ng potential or current changes in the solution. Okay. So tatlo silang nakatusok sa solution. No? So you have the working, it could be a platinum disc, pwede siyang dropping mercury. You have the second, you have the reference electrode. Typically, this is the calomel electrode. Okay. And for the auxiliary electrode, this is the platinum electrode na. So siya lang yung nagtutulong to change the voltage or the amperage of the solution. Okay. So ganun lang. Huwag niyo kabisaduhin yun ha. So these are some examples of voltammetry. The one I showed you on on ito. Yeah. So this one is the cyclic voltammetry, no? So this is one example of the voltammetry. Cyclic voltammetry kaya siya pa circle. Okay? And so ito yung iba't ibang uri pa ng voltammetry. You have the staircase. Literal na ganito yung itsura ng titration curve niyan, staircase talaga, no? Okay. Pag cyclic, yun yung pa duck shape, no? Pa circle, ganun. Yan. Dinosaur na ata yan. Anyway, basta ganun. I have the anodic stripping, cathodic stripping, which is related to this one. Anyway, so hindi mo naman kailangan kabasaduhin yan. Okay, so this is one example of the voltammetry. Mapapansin nyo, you have 3 electrodes pointed into our solution. They are all submerged in the solution. So one of them is the working, the one is reference, and the last one is the auxiliary electrode. So they are all working, no, to determine the potential differences, no, and the current differences sa solution. So this is a very technical topic na kaya yung idea lang binigay ko sa inyo. Okay? Oh, himala. Maga tayo natapos. Okay, so we're done, no? We're done with chapter 6, no? Again, for the calculation part, ito lang mga takeaways natin. For the calculation part, ayan. So for the calculation part, always, no? Always write the Nernst equation. Okay, so we always write the Nernst equation. Again, ano yung Nernst equation? Ito yan. This one. When writing the Nernst equation, make sure that your equation are reduction form. So, dito kayo titingin sa table na to. Tignan mo kung ano yung tsura ng reduction equation na yan. Okay? So, yan. So, ganun lang. Ayun lang naman. Then, yeah, yun lang. Always naka-Nernst equation tayo. Okay? So, that will be all for chapter 6, no? So, how would the quiz will go, no? Ganito yung mangyayari sa quiz natin. So, of course, marami tayong terms, no? So, expect 10 items. And wag na natin gawin 10 items. Gawin na natin 15 items. Concept and terms. Okay? Kasi yun yung marami dito, concept pati terms. And then 5 items lang yung calculation. Okay? So 5 items na lang yung calculation. Para hindi kayo masabaw masyado. Okay? Para mas marami kayong mababawi sa concept and terms. No? So basically, whatever I have written here, no? Iikot-ikutin ko lang yung question na yon. Then, yun yung magiging 15 items ng quiz natin. For the calculation part, 5 items lang yan. Okay? So basically, yung mga yung E-calculation, E-cell calculation. So, I will give you the pattern naman. I will give the worksheet by the weekend. So, you can use that as your guide. No? Okay? So, with that, we're done with our lesson. No? Yun. So, I expected kasi na magmamadali talaga ako until the end. No? Pero yun nga. I skip some parts, no? Especially yung calculation sa titration. So, sa worksheet na lang yun. Anyway, plug-in lang naman kasi yun. No? Parang titration lang din yun. Puro plug-in. Okay? And again, take note of the announcement I made earlier. So, don't forget this. So, for the lecture class, so lecture ko kayo. So, ito yung ating schedule. So, yun. We are done with this. We'll start uploading the answer the quiz by Thursday. And also, this is the deadline of quiz 5, no? Part 1 and part 2. So, please, no? Sagot-sagot kayo. No? May mga naka-perfect. So, kayang-kaya. Yung part 1 naman is concept lang. Part 1 is just concept. So, kayang-kaya. Let me show you. Hindi ko papakita yung questions mismo. And also, multiple attempts yung ginawa ko, ha? Multiple attempts yan. So, for quiz 5 part 1, dalawang attempts. So, ito puro term to. Puro terms to. Okay? Puro terms lang yan. So, kayang-kaya yan i-perfect. Dito may mga naka-perfect. But for part 2, this is calculation. So, whatever I have written on the worksheet, follow that na lang. Okay? Kasi nga, may correction ako last time and I'm sorry for that. No? Kasi, buti na lang nakita ko yung correction because I was looking for questions na ilalagay ko sana sa quiz. Then suddenly nakita ko yung notebook ko. Yung notebook ko na ginamit ko ng board exam. Sabi ko, wala, bakit fraction to? Tapos kita ko nga nung dinerive ko, sabi ko, ay fraction nga. Sorry guys. Kaya yan, pasensya na, ganun na lang na feel ko. Kaya yan, nag-post na lang ako. And I uploaded the worksheet with full explanation. Kaya sinabi ko dun na bakit ganito, ganyan. No? So, yun. So, I'm sorry for that. No? Nagkaroon ako ng oversight. Hindi ko nakita masyado eh. Pero yan, at least na-correct natin. So, again, for this part 2 of the quiz, just follow just follow this one. Ayan. So, ano to? 3 attempts. Yes, 3 attempts yan. Para bawing-bawi na. However, if your answer ay near sa final answer, I mean near siya sa correct answer, then I can consider that, no? Pero again, yung consideration, gagawin ko na lang siya after the deadline. Para isang tinginan na lang, isang upuan lang pag nag-check ako. Okay? So, yan. So, again, don't forget this, deadline by Thursday. So with that, maybe we're done with our session for today. So thank you for attending. Paunti tayo ng paunti, pero okay lang yan. I think you are all busy with your other subjects as well, no? Kaya okay lang naman sa akin. So hindi naman required yung attendance. Yes, may student ako na nag-message na she was asking for longer deadline, kaya yun, binigay ko long deadline, no? Kasi I think ang dami yung ginagawa sa GE, no? Ayan. Kaya ayan. So that's okay with me. I can adjust, no? Pero ayun, again, you still have to study well, no? Especially sa calculation part. And by the way, this is the last hard topic, no? Last na tong hard topic na to. The next topics will be easier. Okay? Mas madali na yung final topics natin. Itong chapter 7, kulay-kulay lang yan. Yung equation na gagamitin mo dito, dalawa lang. Unlike dito na sandamukal, di ba? Ito, dalawa lang. Then chapter 8, I think isa lang yung equation na gagamitin nito. But this is asynchronous. So I am making this last week asynchronous para you have more time to review for your finals. Again, the finals is on May 17 to 22. Please be reminded. Pakisulat na sa calendar nyo. So, I expect you to create a similar calendar. Kaya nagganito na rin ako. Para alam nyo gagawin natin. Okay. So, yun. So, good luck, no? And kailan lalabas yung grades nyo? Mag-i-email muna ako before I upload the final grades, no? So, just like what I did last time. Okay, just like what I did last time sa midterms. Although hindi required yung consultation, I will still give you your tabulation and scores, no? Para transparent tayo. Okay? Para alam nyo saan tayo tumaas, saan tayo bumaba, no? Okay. Para wala tayong issue. Okay? So yan, the grades will be encoded by, I think, ang schedule namin for encoding is 24 to 26. So expect you will see your grades by 27. And that means natapos ang isang year nyo sa school na nasa bahay. So I hope by next academic year, hindi na ako magtuturo ng chem nun eh. I mean, hindi na ako magtuturo ng biochem. So iba na yung hawak sa inyo sa chem. Okay. So yan. So this will be the last semester that I will be with you. No? Kasi ang tinuturo ko lang is org, and anachem. Kasi yun yung maraming math. Yung biochem majors na yun. Okay. So okay. So, I talk too much na. Anyway, so that will be all. No? So I'll see you again next week. And next week will be our last synchronous session. So I'll see you again and bye-bye. Ingat always. If you have any questions, don't hesitate to raise them, ha? My lines are always open naman. Kahit mag-email kayo ng madaling araw, makikita ko yun. Kasi puyat ako always. Okay? So yan.